Hello there! Now this given linear system, both the equations are expressed in general forms. We could see that it's in general form because the right hand side are both zeros, and you could see constants on the left hand side. So we just need to duplicate the same process we did before in solving for this given linear system. We can start with coming up with a standard form equivalent to this, where there are constants on the right hand side, and we just use the process of elimination. Before we start, don't forget that this is called a linear system. In given linear system, these two equations are called linear equations in two variables, for we have two variables here, x and y, and they're also considered to be linear because the exponents of x and y are just equal to 1. And also, if we are going to graph both of this on the Cartesian plane, our graphs would be lined. Now we will not be graphing here, but if you wish to use graphing method, you could see that the point of intersection of the two graphs is actually the solution for this given linear system. But we will be using here elimination method. So let's start by coming up with the standard forms of these two equations. Okay, so I'm going to copy it here, but automatically in standard form. So your first equation would be 5x, and then you have plus 3y. If I'm going to subtract both sides by 12, the left hand side 12 will be removed, and the right hand side will become 0 minus 12 or negative 12. Same thing will go with our second equation. You will have here x, that's x, plus 5y, but I'm going to add both sides by 2. So I have here positive 2. This is now, these two equations now are the equivalent standard forms of the respective given already. Now, we could use elimination method here in the process of eliminating one of the two variables to solve for the other. And that variable that was solved first, we're going to use it to solve for the first variable that we have eliminated. The hint there is, look at the variables if there are multiples of the other. That's easier because if one, the coefficients of x and y, if one of which is a multiple of the other, we can multiply the entire equation by a certain constant that will make it a multiple of the other, opposite specifically, to remove that. Now, for y, 3 and 5, they are not multiple of the other. For x, 5 and 1, but 5 can be multiple of 1, right? So I could multiply this entire second equation by 5 to make it 5x as well. But if I'm going to multiply this with just 5, I cannot eliminate still x, because 5x plus 5x will be 10x, but it will not be eliminated. Instead, I will make here this portion, sub negative 5. So our two equations will be given like this. So the first equation is still in 5x plus 3y. This is still negative 12. But the second equation will be transformed into this form. We have negative 5x. The y coefficient, negative 5 times 5, we have minus, that's minus 25y. And here you will have minus 10. Okay, so negative 5 times 2, that's negative 10. So if we're going to add now the two equations, we can eliminate x. So we will be solving for y first, and then you will have 3y plus negative or minus 25y. You have negative 22y is equal to, the other side will also be negative 22. This would mean that the value of y is positive 1. This is now the value of y, which could satisfy both equations, but we need to have its partner. We're going to look for the value of x. We can use this y and substitute that in any of the two equations to get the value of x. But here's the hint and the suggestion I am going to give you. Use the original equations, not the standard form, nor the equivalent form of an equation by a scalar multiple of any constant. Use the original equation so that if there are incorrect processes in your movement from one to the other, you could also verify if there is. So I'm going to use the original two equations. Okay, so the first equation is 5x plus 3y plus 12 equal to 0. So you have 5x plus 3 times 1, that's the value of y, plus 12 equals 0. So you have here 5x plus 15 equal to 0, 5x is negative 15. X is equal to, that's equal to, dividing both sides by 5, negative 3. This should be the value of x. Now, even if you're already sure with this, we could also verify if the same value of y using the second original equation could still give us a value of x which is negative 3. Now, for some of us, this may seem too taxing, but if you have time, by the way, you can just simply check and verify so that you're really sure about your answer. So, using the original equation, x plus 5y minus 2 equal to 0. So, x plus 5 times 1 minus 2 equal to 0. X is equal to positive 3. Sorry. X plus 3 equal to 0. So you will have it here, x is negative 3. Because 5 times 1 is 5 minus 2, that's 3, right? So you will still get the same result of x. And at this time, you can now say that your solution is a point in the Cartesian plane with the coordinates of x being negative 3 and y being 1. Okay? By the way, if you will decide to remove y first before x, you will still get the same result as long as you verify it. Now, this is already the solution, and you could stop viewing here or pause for a while. But let me just continue for another verification process. This solution should satisfy not just one equation, but both of the original equations. So I'm going to substitute x being negative 3 and y being 1 to any of the two original equations, and we need to get equality at the end. So let me start again, the original. We have here 5x plus 3y plus 12, 0. Substituting the values, 5 times negative 3 for x, plus 3 times 1, plus 12, question mark 0. I'm using question mark because we are on verification process. Okay? Even if it's too obvious, no need to worry about that. Your goal is to make sure that both sides of the equation would be the same. In this case, both sides of the equation would be 0 because your right hand side is already 0. You have negative 15 plus 3 plus 12, question mark 0. Of course, you will have 0 equal to 0. And as mentioned earlier, this solution should also satisfy the second equation. X plus 5y minus 2 equals 0. So you have negative 3 plus 5 times 1 minus 2, question mark 0. Negative 3 plus 5 minus 2, question mark 0. Of course, that's 0 equal to 0. So this is the verification process, and we have proven that our solution being negative 3 and 1 is a solution for this given linear system. Thank you very much for watching.